All right, we're looking at answers for review for test three. Number one and number two just wants me to find the derivative. So we're doing implicit differentiation to find the derivative on number one and number two. So derivative of 2y is going to be 2y prime. Derivative of x squared is going to be 2x. Derivative of sine is cosine. And if I take the derivative of the inside of sine, that's going to give me y prime. Then we want to get the y primes together on the same side. So we subtract cosine y prime over. We factor out the y prime, and then we divide by what's in the parentheses. So there's number one. Number two, derivative of x squared is 2x. And whenever you have product rule and a coefficient in front of the product rule, I always recommend that you put the coefficient out front and then do the product rule inside of the parentheses. So we have first times derivative of the second plus the second times derivative of the first. Derivative of 2y squared is 4y y prime, and the derivative of 5 is 0. Then I distribute right here. So I get a negative square root 3 xy prime, and I get a negative square root 3 y. And we get the y primes together on the same side. So there's that one and that one. They stay. The other two need to move to the other side. So the negative square root 3y turns into a positive square root 3y. The 2x turns into a negative 2x. And when I factor out the y prime, I get 4y minus 3x. I put the 4y first since it's positive. I always like to put my positive stuff in front of my negative stuff. And then we divide by that, and there's my derivative. Okay, same thing on number three, implicit differentiation. So the derivative of tangent is secant squared. Inside stays the same. Then the derivative of the inside. So first derivative of the second plus second derivative of the first. And the derivative of x is 1. Okay, I divided by secant squared here. So that gave me 1 over secant squared. And 1 over secant squared is the same thing as cosine squared. So that leaves me with xy prime plus y on the left. Subtract the y over, and then divide by the x. There's my answer, and it matches with E. Okay, number four, we did this one in class, but we'll do it again. We want the second derivative, and we want to evaluate it at 4, 3. So derivative of x squared is 2x. Derivative of y squared is 2y y prime. Derivative of 25 is 0. Before you can find the second derivative, we need to get y prime by itself. So I subtracted 2x over, and then I divided by 2y, reduced the 2's. That gives me negative x over y. So there's the first derivative. Then we want the second derivative. So the derivative of y prime is going to be y double prime. And then I got to do the quotient rule right here. So bottom derivative of the top minus the top derivative of the bottom all over the bottom squared. Okay. Notice it has y prime in it. Well, we just figured out that y prime is equal to negative xy. So I took the y prime out. I put negative xy in place. Then I just plug 4 and 3 everywhere. So I plug negative 3 here, or sorry, 3 there, which turns into a negative 3. I plug in 4 there, so that's why there's a 4 there. Put a 4 on top and a 3 on the bottom, so negative 4/3. And then 3 on the bottom gives me 3 squared. Gives me this, and then as I think it was Ethan pointed out, at this point right here, I multiplied top and bottom by 3. So negative 3 times 3 is negative 9. Negative 16/3 times 3 gives me just the negative 16, and 3 times 9 gives me 27. Put the numerator together, we get negative 25, and that matches my answer. Number 5, if the position of the particle on the x-axis at time t is given by negative 5t squared, then the average velocity of the particle for 0 to 3 is, so I want average velocity, so that means I need the change in position to be on top and the change in time on the bottom. Well, this is my position function, so to get the change in position, I'm going to plug 3 in. So that's what I got there. I'm plugging 3 in, and then I plug 0 in, and then over 3 minus 0. So that gives me negative 45 over 3. Divide gives me negative 15. Okay, remember, whatever you want the average of, you need the change in the function above. Okay, so the function above velocity is position, so that's why we use position. If I wanted average acceleration, then I want the change in velocity. Number 6, the position of a particle moves along the straight line at any time t is given by s of t equals t squared minus 4t plus 4. So that's the position function. What is the acceleration of the particle at t equals 4? So acceleration is going to be the second derivative of position. So my first derivative gives me a velocity. So that's 2t plus 4. My second derivative gives me acceleration. And in that case, it's 2. Usually, most of the time, we have something to plug into. I would usually plug my 4 in, but in this case, I don't have anything to plug 4 into. So that means my acceleration is always 2. And that's why my answer is 2. All right. 7. Volume of a cone of radius r and height h is given by v equals 1/3 pi r squared h. If the radius and the height both increase at a constant rate of 1/2 centimeters per second, at what rate in cubic centimeters per second is the volume increasing when the height is 9 centimeters and the radius is 6 centimeters? So I need to take the derivative of this. Derivative of v is dv dt. The 1/3 pi is a coefficient, so I put that out front. And then I do the derivative of r squared and h. Since it's being multiplied, that means I need the product rule. So first, derivative of the second plus the second times derivative of the first. Then we plug in everything we know. Plug it in 6 for the radius, so I plug in 6 there. Both of my rates are 1/2, so I plug in 1/2 to both of those. And then my radius is 6 here, and my height is 9. Clean this up, I get 18. Clean this up, I get 54. 18 and 54 gives me 72. Multiply that together, gives me 24 pi. So my answer would be 24 pi. All right. This is our shadow problem. Bonus for those of you watching this video, there will be a shadow problem on the test tomorrow. So make sure you know how to do this problem. A person whose height is 6 feet is walking towards the base of a street light along a straight path at a rate of 4 feet per second. If the height of the street light is 22 feet, what is the rate at which the person's shadow is shortening? And what is the rate at which the tip of the shadow is moving? So we're 6 there, we're 22 there. I always like to do this first piece as X, and I always like the second one to be S because that represents the shadow. Hang on just a second. All right, then we want to set up our similar triangles. So I did 6 over 22 equals S over the whole side, which is X plus 8S. So then I cross multiplied, gave me 6x plus 6s. That's tough to say for me. And then 22s on the right side. Move the s over, gives me 16s. Take the derivative of both. So derivative of 6x is 6 dx dt. Derivative of 16s is 16 ds dt. They told me dx dt was 4. Notice that it's negative 4 because our person is walking towards the base of the street light. So we're walking from here to there. So that means the distance of this thing is getting smaller. If something's getting smaller, then that means its rate has to be negative. So make sure you pay attention to that. So that gives me negative 24 divided by the 16 gives me negative 3/2. Now notice when I wrote my answer is positive. That's because it says what is the rate at which the person's shadow is shortening. So since they said shortening, that takes the negative out. They already know that it's negative, so all I have to do is put the positive. And then at what rate is the tip of the shadow moving? That's going to be the rate at which this rate and this rate added together. So this rate is negative 4. This rate is negative 3 over 2. And put those together, you get negative 11 over 2 feet per second. Now notice this time I did keep the negative. That's because it didn't say anything about which direction it was moving. So I had to put the negative in there or say that it's shortening. One of those two you had to do. Number 9, particle moves along the line, so its position at any time t greater than or equal to 0 is given by s of t equals t cubed minus 3t plus 2. Instantaneous velocity, that just means take the derivative and plug in. So I took the derivative, I plugged in 3, and we got 24. Find the acceleration. So that means I need the derivative of velocity, and then I plug in, so 6 times 4 gives me 24. Then we have find the average acceleration. So if I want average acceleration, that means I need the change in velocity, which is what you see there, over the change in time. So if I plug 5 into the velocity function, which is right here, I plug 5 in there, minus I plug 1 in, gives me that, ends up giving me 72 on the top over 4. I reduce that, that gives me 18. So my average acceleration is 18. When is the particle moving to the left? So always set your velocity equal to 0. Figure out when it's 0. In this case, it's negative 1 and 1, but this says t has to be greater than 0. So I start my sign line at 0. I put 1 on my sign line, and then I plug a number in on each of these into my velocity to see if it produces a positive. So if I plug in 2, obviously going to be positive. If I plug in 1/2, that's going to give me a negative. Because 1/2 squared would be 1/4. 3 times 1/4 is 3/4. 3/4 minus 3 is going to give me a negative. So left goes with the negative sign. So that means we're negative from 0 to 1. So that means we're moving left from 0 to 1 because velocity is negative. F is speed increasing or decreasing at t equals 2. So if they gave me a function like they did here, then that means we need to know what's my velocity and acceleration at that point. So that's what I'm doing here. I plugged into velocity to get my velocity at 2. I plugged into acceleration to get acceleration at 2. And since the signs of both of these are the same, then that means speed is increasing because v of 2 and a of 2 have the same sign. Number 10. Position of the particle is given by x of t. So we have a position. Excuse me. Find the acceleration at t equals 0. So acceleration is going to be the second derivative. So the first derivative gives me that. The second derivative gives me that. Make sure when you're finding the derivative of these things, make sure you're taking the derivative of the inside. Because a lot of you would just do cosine and forget to take the derivative of 3t. Because that's how we get the derivative of, or that's how we get 3 out front, and that's how we get 4 out front. So don't mess that up. That's a common mistake. So there's my second derivative, and we plug in 0. So cosine of 0 is 1. 1 times negative 9 is negative 9. Sine of 0 is 0. 0 times 16 is 0. So my acceleration is negative 9. This should be, I think Ethan pointed it out, that should be A. It was either Ethan or Xavier, I can't remember. That should be A instead of B. What does the answer to part A tell you about the velocity at t equals 0? And velocity is decreasing because acceleration is negative. Is speed increasing or decreasing at t equals 2? So again, that means I need to know what's velocity and what's my speed, or my acceleration. We already discussed that acceleration was negative 9. So then I need to plug 0 into velocity, which we got negative 4. Negative 4 and negative 9 are the same sign. So that means speed is increasing. And again, because a of 0 and v of 0 have the same sign. 11, we're looking at a graph. The graph is velocity. When is the object at rest? That means when my graph touches the x-axis. So we touch the x-axis at 5 and we touch the x-axis at 8. So at t equals 5 and 8, because velocity is 0 at those points. Okay. If we're at rest, then that means velocity velocity is neither increasing or decreasing. Or velocity is neither positive or negative. Because if velocity is positive, then that means I'm going to the right or up. Velocity is negative, I'm going left or down. So if it's 0, then that means it's not going right or left or up or down. Identify the time when the particle changes direction. So that's going to be when it crosses the x-axis. So it only crosses the x-axis at 5. And our justification is at t equals 5 because v changes from positive to negative. You could also say velocity just changes signs. Either one of those would work. From 3 to 5 is the speed of the object increasing or decreasing. So 3 to 5, if it's speed and we're looking at a velocity graph, then I want to know, is my velocity positive or negative? Is my velocity increasing or decreasing? So from 3 to 5, velocity is positive, and 3 to 5, velocity is decreasing. So since I have a positive and decreasing, they don't go together. So that means speed is decreasing. Remember, they have to go together in order for speed to be increasing. So they have to be positive and increasing or negative and decreasing. That's how speed would be increasing. D, on what intervals is the acceleration of the object positive? Acceleration is positive when velocity is increasing. So velocity is increasing between 1 and 3. It's also increasing between 7 and 8. Whoops, I wrote that down wrong. That right there should be 3. So 1 to 3, 7 to 8 because velocity is increasing. So make that correction for me. Average acceleration of the particle from 1 to 6. So that means I need the change in velocity. I need to know what's my velocity at 6. So at 6, my velocity is negative 2. So that's why that's there. At 1, my velocity is 1. So that's why that's there. And then over 6 minus 1. So that's going to give me negative 3 over 5. Okay, then we have our L'Hopital's rule problem. Remember, you want to plug in and make sure you can use L'Hopital's. Remember, you can use L'Hopital's when you have 0 over 0 or infinity over infinity. So I plug in 0, sine of 0 is 0. I plug in 0, that's 0, so my numerator is 0. Plug 0 to the bottom, it's also 0. So that means I can use L'Hopital's. So derivative of sine is cosine. Don't forget to take the derivative of the inside, which is 3, so that's why that 3 is there. Derivative of 7x is 7. Derivative of 5x is 5. So then we plug in again. I plug in 0. Cosine of 0 is 1. 1 times 3 gives me 3. And then I have 7 and 5, so I showed you some extra steps there. There's plugging in 0, and cosine of 0 is 1, so 3 times 1 plus 7 gives me 10. 10 divided by 5 gives me a limit of 2. So the limit of this right here is equal to 2. And the last one, plug in infinity, or if I plug infinity to a natural log, that's just infinity. I plug in infinity on the bottom, I'm also infinity. So I take the derivative of each piece. Derivative of 3 is 0. Derivative of natural log of x is 1 over x. Derivative of x squared is 2x. And derivative of 7 is 0. So I get 1 over x over 2x. That reduces to 1 over 2x squared. I plug in infinity again. A number over infinity is equal to 0. So the limit of that right there is equal to 0. Alrighty, there are your answers to review for test 3.